This is 9.4b, continuing on with some examples. So if I do example C that I've given you, we want to prove by mathematical induction that a factor of n cubed minus n plus 3 is 3. So the first thing that we do is that we show that this works for n equal to 1. We designate that with p sub 1. So what we do is we go ahead and plug in 1 into this and make sure that it is a factor of 3. So when I do that, 1 cubed minus 1 plus 3, yeah, it's 1 minus 1. So it's just 3. So 3 is a factor of 3, should say of, okay? So then the next step that we do is we go ahead and show that P of k, or we assume P of k is true. So we assume that k cubed, in terms of k, minus k plus 3 has a factor of 3. We assume that this is true. That's the second step. And pause if you have to. I'm doing this kind of quickly. Then the next one is that assuming part 2, we need to show that p sub k plus 1 does have a factor of 3. And so that's what we want to do. So we write out this thing right here. Instead of n, we're going to put in k plus 1. And then show that that thing does have a factor of 3. So there we have it. K plus 1 quantity cubed minus k plus 1 plus 3. That's just taking k plus 1 and putting it in here for the n's. Now what we want to do is expand. So I'm going to expand this left-hand side and combine some like terms. So k plus 1 quantity cubed is k cubed plus 3k squared plus 3k plus 1. And then I have minus k minus 1. So that comes from there, and then plus 3. And then if we scroll down here a little bit, then the next step, one of our goals here is that we need to find this k cubed minus k plus 3 again. That's one of our keys. So I start looking for this k cubed, I start looking for this minus k, and this 3. So I start seeing these things here. So those are the ones that I want to key in, because if I can group those together, I already know that that has a factor of 3. So I try to get back to this original piece that I did have. So I find those 3 terms, and I'm going to group them together. So I take the k cubed minus k, and then the plus 3, and put those all together, because I know this thing in red does have a factor of 3. Ooh, now look at over here. What happens with these 1s? Well, with those 1s, they go away, and I'm just left with 3k squared plus 3k. I can factor out a 3. Oh, if I factor out a 3, then this term will have a factor of 3. This one we've assumed to have a factor of 3, so we should be in business, because if both, in a sum, if both terms have a factor of 3, then we're good. And you should write this out like this. So pause once again if you have to. Then in conclusion, we're going to say that since P1 is true, that's way back up here, we plugged in 1, that's good. And then we have P sub k plus 1 is true, because the sum of 3 factors of 3, so I have 1 here and 1 here, will also have a factor of 3. So by mathematical induction, we can conclude that a factor of n cubed minus n plus 3 is 3 for all n greater than 1. So we showed it for the n equal to 1 case, and then the p sub k plus 1 case. Pause this if you have to. Okay, then we're going to do a new example, letter D. Yeah, I made it disappear there. Okay, so if we want to prove that this exponential, now this exponential has a little trick that we have to do with it that's a little bit different than part C. But if we have 6 to the n minus 1 is divisible by 5, and that's what we want to prove, we need to show by mathematical induction. And so with n equal to 1, I should have written P1 here, but with n equal to 1, what we want to do then is we want to plug in 1 and show that it is divisible by 5. So with this, I plug in 1. Is that divisible by 5? Yes. If I simplify this, this is just 5 is divisible by 5. No problem. Okay, then I want to go on to the next one where I say that P sub k is assumed by what we're doing. So this would be P sub k we assume that this is divisible by 5, and that is true. Then the third step is that we want to show that the p sub k plus 1 does have a factor of 3. So we're going to take wherever we see the n and plug in k plus 1. So we want to simplify this. This one has a few little tricks in it that we got to be careful with. But what we do first of all with this k plus 1 is that we break this into two pieces. Why can we do this? Well, we do know that if the base, well, let's work in reverse. If the bases are the same, we add the exponents. So I'm going over to this side, we add the exponents. I'm given the sum of the exponents, and so I'm going to split it up into two bases, and that's what I did. I have a sum on the exponents, I split it up with the two bases. The next trick is that we want to get back to this right here. I do not see 6 to the k minus 5. I'm sorry, minus 1 in this, but I need it. So I'm going to put a 6 to the k in there. And when I do that, I have to do a little trick. I have to not only put it in, but I have to take it out as well. So I like to see this right here because I know this little piece right here is divisible by 5. And then my goal is to just try to get this piece divisible by 5, and then I'm good to go. So all I did with this stuff in red is subtracted, added it, put it in. Then the next step is to say, okay, this one right here has 6 to the k. This one right here has 6 to the k. So what I'm going to do is I'm going to factor it out. And when I factor it out, I'm left with this 6, and I'm left with 1. And now I hope you can see what's happening here. 6 minus 1 is 5. So if I have 5 times anything, that will be divisible by 5. Since I have 6 to the k minus 1 is what we had, that's what we wanted to shoot for. That's why I had to put this one in at this point. Yeah, that's divisible by 5 too, by assumption. Both terms are divisible by 5, and so I wrote the first one has a factor of 5, and the second one is by assumption. Then my conclusion for this one, well, think about what things you have in the ingredients. Remember that n equal to 1, we've proven, and then k plus 1, we've also shown for this. So since p sub 1 is true and p sub k plus 1 is true because the sum of the terms is divisible by 5, the sum will also be divisible by 5, and so by mathematical induction we can conclude that 6 to the n minus 1 is also divisible by 5 for n greater than or equal to 1, the integer values. Okay, I hope this helps you with a couple different examples that are a little bit different than the sequence ones that we did before. Thank you very much. Have a great day and good luck on all your tests if you do have some coming up.